Okay, so we have the gradient for the first one and second one. That's the first one's gradient. Let's call that M1. And the second one's gradient, let's call that M2. And we have C1. And for this one, C2. And yesterday we solved that M1 not equals to M2. We give the value that K is not equals to 1 plus minus root 2. Okay, K is not equals to 1 plus minus root 2. That's what we solved yesterday. And then the second one is no solution. Okay, that's for infinite. That's for unique solution, and we have no solution. Okay, we're trying to solve for no solution. We need M1 equals to M2. C1 not equals to C2. Okay, so that's the equation I gave to you yesterday. 1 minus K over 2 equals to 1 over K minus K. A half not equals to K over 1 minus K. So they are parallel, but they are not the same line. So let's solve for this. Okay, for the second one, let's talk about the second one now. For the second one. For the first equation, we already solved out that K equals to 1 plus minus root 2. Okay, that's what we already know. We have solved that for the first part. Okay, we already solved out that. And for the second one, for C1 not equals to C2. So we need to first to solve C1 equals to C2. Okay, if you solve C1 equals to C2, you will solve out K equals to 1 on 3. I'm not sure if you have solved out this answer. Okay, I give this to your homework. If you have solved out K equals to a third, that will be correct. Okay, so you have the first one, you solve out K equals to 1 plus minus root 2. For the second one, K not equals to a third. Because when they equal, K equals to a third. You want this not equal, the C value not equal, so K cannot be a third. You want to satisfy both. Okay, you want to satisfy both. So you want K equals to 1 plus minus root 2. And at the same time, you want K not equals to a third. So to make this conclusion, K will equals to 1 plus minus root 2. When K equals to that, there will be no solution. Okay, there will be no solution. Because think about, you want to satisfy the parallel. There are only two values can make that parallel, which is K equals to 1 plus or minus root 2. They are parallel already. And you want them not have the same y-intercept. So if K not equals to a third, they will never have the same y-intercept, which K equals not equals to a third. So you go back to check your K value at the beginning. It's not equals to a third, so you won't have the same C value. So K equals to 1 plus minus root 2 will be no solution. Then therefore, you want the third one. You want there will be infinite many solutions. So in this case, you want so first one you want M1 equals to M2. That will give you K equals to 1 plus minus root 2. And then you want C1 equals to C2. So you will have K equals to a third. You need to find a K value can satisfy both equations because it's an AND relationship. And you can find that there's no such K values. Okay? So to make C equal, you need K equals to a third. To make M equal, you need K equals to those two values. But there's nothing in common, which means there's no such K value. To give infinite many solutions. So there's no K value will satisfy this. Okay. Okay, have a think about the question, what we have done. So basically, we are talking about two things. One is the gradient, one is the y-intercept. Okay, for the first case, just the gradient not equal. For the second case, we want the gradient equal, but the intercept not equal. For the third case, we want the gradient and intercept both equal. So basically, we just talk about two things. Okay, and you check the k values. Let's do another example. Let's see if there's a better understanding or not. Let's do question 2. Let's do question 2. So first of all, I want you to make y to be the subject. Okay, I want you to make y to be the subject. So make y on one side and make the equation into the gradient and intercept form. Okay, if you have read this, we'll have minus k over 8x plus k minus 4 over 8. That's for the first linear. And for the second one, we have y equals to minus 3 over k minus 2x plus 1 over k minus 2. So we have k1 equals to minus, m1 equals to minus k over 8, m2 equals to minus 3 over k minus 2. And we have k minus 4 over 8 is c1, and k1 over k minus 2 is c2. So let's think about for the unique solution. For the unique solution, what we need? We need the two gradients not equal to each other. They will have an intersection. So what we need is 1 minus k over 8 not equals to minus 3 over k minus 2. Okay, to solve they are not equal, I will solve for equal first. Okay, I will solve for equal first, and then k not equals to that value will be those two gradients not equal. So I can times in that way. Okay, k times k minus 2 equals to 24. That's a quadratic. Okay, you have k times k, that's a quadratic. You cannot solve quadratic in this form. Okay, that's not the standard form. So I will open the bracket, that's k squared minus 2k minus 24 equals to 0. And if you know how to factorize that, I will have k minus 6 times k plus 4 equals to 0. Okay, k minus 6 times k plus 4 equals to 0. And I will solve out that k equals to 6 or k equals to negative 4. Okay, k equals to 6 or k equals to negative 4. Okay, so for unique solution, let's say that's number 1. For unique solution, you want the gradient not equal. If k equals to 6 or equals to negative 4, they will be equal. So for the first one, k not equals to 6 or -4. Okay, that will be the answer for the first one. For unique solution, you just need the gradient not equals to each other. Okay, so this equation is what we solve for M1 equals to M2. Okay, we solve for M1 equals to M2 for the first one. Let's think about the gradient equal and the intercept equal. C1 equals to C2. So if the 2y intercept will be the same, which I can write k minus 4 over 8 equals to 1 over k minus 2. Okay, 1 over k minus 2. And I can do k minus 4 times k minus 2 equals to 8. Again, this is not the standard form for quadratic to solve. I need to open the bracket and put everything to the left and one side to be 0 to solve for it. So I will have k squared minus 4k minus 2k will be a minus 6k. And plus 8 equals to 8. Okay? And the 8 and 8 on both sides, that will be a 0. So I will have k squared minus 6x. So I can factorize as k times k minus 6 equals to 0. Okay, I factorize k times k minus 6 equals to 0. So I will have k equals to 0 or k equals to 6. Okay. K equals to 0 or k equals to 6. Okay, that's when k equals to 0, your C value. Okay, let's think about k equals to 0. Can k really become 0? Think about what will happen when k equals to 0. Go back to the original equation. Think about that. If k equals to 0, the x term just gone, right? What we have left for the first equation is 8y equals to -4. Y equals to -1/2. And for the second one, k equals to 0, I will have 3x minus 2y equals to 1. Okay, so for y equals to -1/2, is that still a linear? Is that still a linear? What's the graph looks like for y equals to -1/2? It's a line? Yeah? Horizontal or vertical? Horizontal, right? And you will have intercept as -1/2. Y-intercept, right? It's a horizontal line, pass through -1/2. Okay, it's a horizontal line. So it is still a linear. So there's nothing wrong with k equals to 0. You still have a linear, just it's a special linear. It's just a horizontal linear. Okay, when you learn linear in year 10 or year 9, there will be special type of linear. There's vertical linear and horizontal linear, and the linear only pass through the origin. So when k equals to 0, that is still a linear. There's nothing wrong. So you can keep this value k equals to 0. Okay, you just, when you see k equals to 0, you may ask yourself, is that alright? You want to go back and check. Because for a lot of questions, k equals to 0 can be a problem. Okay, if you go back to check, it may cause some problem. So for this one, I go back to check that there's nothing wrong. This is a linear, that is still a linear. They're both linears, so k equals to 0 is alright. So now I have solved out k equals to 0 or k equals to 6 can make the y-intercept to be the same. Okay, for my second question. My second question wants no solution. I want no solution. So under what case I can have no solution? So first I need M1 equals to M2. And I need and at the same time I need C1 not equals to C2. Okay, I need M1 equals to M2 and C1 not equals to C2. Okay, in this case, K equals to 6 will make the two gradient equal. But K equals to 6 will also make C1 equals to C2. So K equals to 6 cannot be the answer. Can you see that? If K equals to 6, okay, if K equals to 6, the gradient is equal. But at the same time, K equals to 6. This one will also be equal. If not satisfied, it's not equal here. So K equals to 6 is not the answer. And K equals to -4 can make that equal. K equals to -4 can also make that not equal. Okay? So K equals to -4 will be correct. Can you see that? K equals to -4 will be correct. So why 6 cannot work? Because K equals to 6 will make the intercepts equal, which is infinite many solution. So I need this can make them parallel, at the same time can make the y-intercept to be different. So I will take K equals to -4 as my answer. So K equals to okay, my question is, K equals to 0 should be an answer or not? Do you think K equals to 0 will be an answer for the second part? Okay, K equals to 0. Do you think I should answer K equals to 0 here? Okay, think about what K equals to 0 do. K equals to 0, will the gradient be the same or different? Different, so it's not satisfied. Okay, K equals 0 is nothing to do with this answer. Okay, it just can make the intercept to be equal. Okay, so K, you just think about those two values. Okay, it's those two values. Okay, number 3. Okay, number 3. Okay, number 3 is infinite many solution. I need M1 equals to M2 and I need C1 equals to C2. So I need M1 equals to M2 and I need C1 equals to C2. So K equals to 6 will make M1 equals to M2. K equals to 6 can also make C1 equals to C2. So K equals to 6 will be the answer. Okay, think about K equals to -4. K equals to -4 will make the gradient be equal, but K equals to -4 will not make the C1 equals to C2. So K equals to 6 will be the final answer. Okay? K equals to 6 will be the final answer. So for the first one, you just need all the real numbers except 6 or -4. Okay, K can be any other numbers except 6 and -4 because 6 and -4 will make them parallel. If they are not parallel, they will have a unique solution. For the second one, you want no solution. You want them parallel, but you don't want them to have the same y-intercept, which means K equals to -4 will satisfy. And the third one, you want infinite many solutions. Okay, you need them parallel and you need the same y-intercept. In other words, you need two identical equations. Okay, you want two identical equations. You want the m value to be the same and the c value to be the same, which K equals to 6 will give you that. If you can substitute K equals to 6 back here, you will have exactly the same equation. Okay, you have exactly the same equation. So that's how you do this type of questions. There definitely will be one multiple choice or one short answer questions on your VC exam. Okay, in year 12. This will appear again in year 12. And that's the worst done question, I think, from last year, year 12. Like, when they do revisions, they feel like, I still don't know what to do for this type. So I have explained very early here. I hope you can still remember after a year study. Okay, so you need to discuss that. You just need to discuss the gradient and you need to discuss the intercept. And you think about, okay, 3 cases. Okay, 3 cases can give you unique solution, no solution, and infinite many solutions. Okay, all right. And one thing I need to talk about is, okay, I will clean here first. Okay, I will upload the final solution for you, don't worry, but I will clean here first and to write another thing. Okay. When we talk about infinitely many solution, okay, when we talk about infinitely many solution, let's think about for this particular question. Okay, you know k equals to 6 will give you two identical equations, right? So you just substitute k equals to 6 in one equation is enough. So let's substitute k equals to 6 in one equation. Let's choose the easier one. I think the second one is easier. So let's substitute k equals to 6. So that's 3x plus 4y equals to 1. Okay, 3x plus 4y equals to 1. Let's make that form. So 4y equals to minus 3x plus 1. And y equals to minus 3 over 4x plus 1. Okay, so you know that if you substitute k equals to 6 in the second equation, you will have identical equation, right? You have identical one. Okay, my question here is, how can you represent all your solutions out? We will have infinitely many solutions, right? Every single point on this line will be the solution. How we can use a way to represent this out? If you can go back to this page. Okay. See part A. This is called describe the solutions through the use of parameter. Okay, through use of parameter. You need to understand, like you need to know what this question is asking. What means by use of parameter? So we will have infinitely many solutions. All the solutions is on this linear. Okay, we want to use a way to represent that out. Okay, we want to use a way to represent that out. We don't want to list every single one. You cannot. So what we can do is, okay, tell me every single point on this linear will be the solution. So let's suppose we have x equals to alpha. X equals to alpha. What is the y value? Y will equals to negative 3 over 4. Alpha plus 1. Okay, negative 3 over 4 alpha plus 1. What is alpha? Alpha can be anything. Okay, what is alpha? Alpha can be any number. 1, negative 1, negative 100.
Isn't it 1 by 4?
Oh yes, 1 by 4, sorry. That's 1 by 4, yes. That's 1 by 4. I forgot to divide that. Thank you. And this will be a quarter. Oh, that's 1. Okay, so or we can write. Okay, if we suppose x is alpha, so x is some number. So y value must be that number times negative 3 over 4 and plus 1. Okay, that's the corresponding y value. So we can write that in the coordinates form. We will say alpha is the x value, negative 3 over 4 alpha plus 1 is the y value. And that is your solution. Okay, that is your solution. That's called the perimeter. Use the perimeter to talk about the solution. Okay, you list, like, that's one coordinates. But according to the change of the alpha, you will have infinite many solutions, right? You just write out one coordinates. But if alpha change from 1, change to 2, change to 4, change to 100, you will have infinite many solutions. So this is the final answer. Okay, that is use the perimeter way to represent your solution out. Okay, you can go back here to see here. Okay, see, oh, no. That's a perimeter way. Can you see that? So this part is use the perimeter way to represent your solution out. Okay, so I want you to spend 10 minutes. I'll give you 10 minutes on question C. I want you to do question C by yourself.